Hello, for today's video lecture we're going to be talking about trusses. So a truss is a type of engineering structure where all the members in the structure are two-force members. Here is an example of something we might describe as a truss. So in this truss bridge, all of the beams are connected at their endpoints, and we're going to have forces acting at those endpoints, and therefore they're all going to be two-force members. So all two-force members are either going to be in tension or compression. They are going to be have forces acting on them. They're going to be equal and opposite and acting along the line of action between the two endpoints of the beam. So trusses can further be broken down into plane trusses and space trusses. So a plane truss is a truss that exists entirely in one plane. And this is essentially just a 2D truss. So here are some plane trusses that are used for roofs. So we've got a whole stack of them in there. And essentially this is going to be a 2D truss. And this means we're going to analyze these trusses as 2D systems. And sometimes we can approximate parts of a 3D structure as a plane truss. So here in this bridge, we've essentially got two plane trusses on the sides, and then what's known as stringers, or kind of horizontal pieces that aren't going to carry much of the load, just connecting those two side pieces. So here we would also approximate this as a plane truss, kind of look at the side view of the bridge and see where the forces are acting in that system. So alternatively, we have a space truss. A space truss is a truss that does not lie in a single plane, hence it occupies space. So here we've got an example of a space truss that is used to support a roof. So we've got a complex series of tetrahedrons. It's actually with this, tetrahedron would be three sides. It's an upside down pyramid, but we've got this repeating pyramid pattern in a truss. So also over here we've got an example. So this tower here is a truss, but it really can't be broken down into a 2D shape. So this means that we're going to analyze these trusses as fully 3D systems. All right, so what are we looking for with this? So when we analyze any structure, we are trying to determine the forces acting on each individual member in the structure. So if each member is a two-force member, we need to find the magnitude of the force. So how strong is the force, either tension or compression, and we need to determine if the member is in tension or compression. Because they're going to react differently, something might break in compression before it breaks in tension. So we need to identify all those forces and all the pieces, either tension or compression. So methods for analyzing trusses. What do we do if we have a truss? So we're generally going to have kind of one of two methods. We're going to have the method of joints, which is going to focus on the connection points where the members come together, the joints in the method of joints. And this is generally the fastest way to solve for all the unknown forces. So if we want to analyze the entire truss, method of joints is usually what we use. Alternatively, we have the method of sections. This involves theoretically cutting the truss into multiple sections, and then we're going to analyze each of those sections individually as a rigid body. So if we want to find the forces in a specific member, a specific targeted member, the method of sections is going to let us go and jump straight to the forces in some specific member. And it's going to be the fastest way to kind of jump to a specific location. We can also kind of use a hybrid of these two methods, the method of joints and methods of sections together, and we kind of flip back and forth between what we're using if we are doing something somewhere in between. So I need to find 5 or 6 specific members. I might use a hybrid method, start with the method of sections, and then kind of use the method of joints to spread out from there. So these are our methods available for analyzing trusses. And that's all we have for today's video lecture. Thank you for watching, and I hope to see you again.